Armorite MC cable is a type of metal clad cable that is used for electrical wiring. It is similar to BX cable, but it has a number of advantages over BX. Firstly, Armorite MC cable has a more durable outer jacket than BX cable, making it more resistant to damage from impact, abrasion, and moisture. Secondly, Armorite MC cable has a higher current carrying capacity than BX cable, meaning that it can be used for higher power applications. Thirdly, Armorite MC cable is more flexible than BX cable, which makes it easier to install in tight spaces. In addition to these advantages, Armorite MC cable is also listed for use in wet locations, making it a good choice for outdoor applications or for areas where there is a risk of water exposure. One key difference is the grounding method. With BX cable, the outer jacket is used as the grounding conductor. With Armorite MC cable, the grounding conductor is a separate bare aluminum wire that is run inside the cable. This grounding conductor is connected under the ground screw at the termination point. The grounding method for Armorite MC cable is more reliable than the grounding method for BX cable because the grounding conductor is not exposed to the environment and is therefore less likely to be damaged. Overall, Armorite MC cable is a good choice for electrical wiring, offering durability, higher current carrying capacity, increased flexibility, and greater reliability than BX cable. When installing Armorite MC cable, always follow the manufacturer's instructions and all applicable electrical codes. It is crucial to select the correct size of cable for the intended application to ensure it can safely handle the expected current load. Using a cable that is too small can lead to overheating, posing a fire hazard. Likewise, ensure that all connections are made properly and are securely tightened to prevent loose connections, which can also cause overheating and arcing. Terminate the Armorite MC cable using only connectors that are specifically listed for use with this type of cable. These connectors are designed to ensure a proper and reliable connection to the equipment grounding conductor, which is critical for safety. When cutting the cable, use a cable cutter or a hacksaw with a fine-tooth blade. Be careful not to damage the conductors or the insulation. After cutting the cable, deburr the cut end to remove any sharp edges that could damage the conductors or the connector. When installing the connector, follow the manufacturer's instructions carefully. Make sure that the connector is properly tightened to ensure a good electrical connection. The bare aluminum grounding/bonding conductor, which is often one size larger than the circuit conductors, needs special attention. Cut the aluminum ground about 1 inch beyond the armor and fold it back over the armor as instructed by the manufacturer. This step is vital for ensuring a reliable ground path. Remember that Armorite MC cable is available in 2, 3, and 4 conductor configurations and in number 14, 12, and 10 American wire gauge. Choose the appropriate size and configuration for the specific application. For instance, a 12 American wire gauge cable is typically used for 20 amp circuits, while a 14 American wire gauge cable is used for 15 amp circuits. Always check the ampacity of the cable to ensure it meets the requirements of the circuit. When working with electrical systems, it is essential to adhere to all safety precautions. Always turn off the power to the circuit before working on any electrical components. Use appropriate personal protective equipment, such as gloves and safety glasses, to protect yourself from electrical hazards. If you are not comfortable working with electrical systems, it is best to hire a qualified electrician. They have the knowledge and experience to safely and correctly install electrical wiring. In wet locations, ensure that you use Armorite MC cable that is specifically listed for wet locations and that you use connectors that are also listed for wet locations. This will help to prevent water from entering the cable and causing corrosion or electrical shorts. Regularly inspect electrical wiring to ensure that it is in good condition. Look for signs of damage, such as cracks, cuts, or discoloration. If you find any damage, have it repaired by a qualified electrician. Proper grounding is critical for electrical safety. The grounding system provides a path for fault current to flow back to the source, which helps to trip the circuit breaker or fuse and prevent electrical shock. Make sure that the grounding system is properly installed and maintained. Use a multimeter to test the continuity of the grounding system to ensure that it is working properly. Familiarize yourself with the National Electrical Code, or NEC, which provides detailed requirements for electrical installations. The NEC is updated every 3 years, so it is important to stay up to date on the latest changes. The NEC covers a wide range of topics including wiring methods, overcurrent protection, grounding, and bonding. Understanding and following the NEC is essential for ensuring electrical safety. When selecting electrical equipment, make sure that it is listed by a recognized testing laboratory, such as Underwriters Laboratories or all. Listed equipment has been tested and certified to meet safety standards. Using listed equipment helps to ensure that the electrical system is safe and reliable. Consider using arc fault circuit interrupters, or RSIs, to protect against arc faults, which are a common cause of electrical fires. RSIs are designed to detect arc faults and to trip the circuit breaker before a fire can start. They are particularly useful in bedrooms and other areas where people are likely to be sleeping. Ground fault circuit interrupters, or GFCIs, are another important safety device. GFCIs are designed to protect against ground faults, which can cause electrical shock. They are required in bathrooms, kitchens, and other areas where there is a risk of water exposure. Understanding the different types of overcurrent protection devices is also crucial. Circuit breakers and fuses are designed to protect electrical circuits from overloads and short circuits. They are rated in amps, and it is important to use the correct size of overcurrent protection device for the circuit. Using an overcurrent protection device that is too large can allow the circuit to become overloaded, which can cause overheating and a fire. Always refer to the NEC for guidance on selecting the appropriate overcurrent protection device. When working with electrical panels, be extremely careful. The electrical panels contain live electrical parts, and it is easy to get shocked if you are not careful. Always turn off the power to the panel before working on any electrical components. If you are not comfortable working with electrical panels, it is best to hire a qualified electrician. Remember, electrical safety is paramount. Taking the time to learn about electrical systems and to follow safe work practices can help to prevent accidents and injuries. Consider taking an electrical safety course to learn more about electrical hazards and how to protect yourself. The National Fire Protection Association, or NFPA, offers a variety of electrical safety courses. Also, be aware of the potential hazards associated with aluminum wiring. Aluminum wiring was used in many homes built in the 1960s and 1970s. It has been found to be more prone to loosening and overheating than copper wiring. If you have aluminum wiring in your home, it is important to have it inspected by a qualified electrician. They can recommend ways to mitigate the risks associated with aluminum wiring, such as installing special connectors or replacing the aluminum wiring with copper wiring. Be sure to properly label all electrical circuits. This will help you to identify the correct circuit when you need to turn off the power for repairs or maintenance. Use a circuit directory to keep track of the circuits in your electrical panel. When adding new circuits, be sure to follow all applicable electrical codes. This includes obtaining the necessary permits and having the work inspected by a qualified electrical inspector. Ignoring electrical codes can create safety hazards and can result in fines. Remember to properly support electrical wiring. Use cable ties or straps to secure the wiring to studs or joists. This will help to prevent the wiring from sagging or becoming damaged. Do not run electrical wiring through holes in metal studs or joists without using grommets or bushings. This will protect the wiring from being damaged by the sharp edges of the metal. Ensure that all electrical boxes are properly grounded. This will help to prevent electrical shock. Use a grounding clip or screw to connect the grounding wire to the metal box. When installing recessed lighting, be sure to use fixtures that are rated for use in insulated ceilings. These fixtures are designed to prevent overheating and fire hazards. Follow the manufacturer's instructions carefully when installing recessed lighting. Consider using energy-efficient lighting, such as LED lights. LED lights use significantly less energy than incandescent lights, and they last much longer. This can save you money on your energy bills and reduce your environmental impact. Remember to recycle old light bulbs properly. Fluorescent light bulbs contain mercury, which is a hazardous material. Take them to a recycling center for proper disposal. Be aware of the potential hazards associated with extension cords. Extension cords are intended for temporary use only. Do not use them as a substitute for permanent wiring. If you need to run power to an area where there is no outlet, have a qualified electrician install a new outlet. Do not overload extension cords. This can cause them to overheat and create a fire hazard. Use extension cords that are rated for the intended use. For example, use a heavy-duty extension cord for power tools. Inspect extension cords regularly for damage. If you find any damage, replace the extension cord immediately. When using power tools, be sure to follow all safety precautions. Wear safety glasses and gloves to protect yourself from injury. Use power tools that are in good working condition. Do not use power tools in wet locations unless they are specifically designed for use in wet locations. Be aware of the potential hazards associated with overhead power lines. Stay at least 10 feet away from overhead power lines. If you are working near overhead power lines, be sure to use caution and to avoid contact with them. Contact with overhead power lines can be fatal. When digging, call your local utility company to have them mark the location of underground utilities. This will help you to avoid damaging underground power lines, gas lines, and water lines. Damaging underground utilities can be dangerous and can cause service disruptions. Be aware of the potential hazards associated with static electricity. Static electricity can ignite flammable materials. Take precautions to prevent static electricity when working with flammable materials. Ground yourself before touching flammable materials. Consider using a static dissipative mat. Remember that electrical systems are complex and can be dangerous. If you are not comfortable working with electrical systems, it is best to hire a qualified electrician. They have the knowledge and experience to safely and correctly install and maintain electrical wiring. Stay informed about electrical safety and follow safe work practices. This will help you to protect yourself and others from electrical hazards. Consider attending workshops and seminars on electrical safety to stay up to date on the latest information and best practices. The more you know about electrical systems, the safer you will be.